What we want to do now is to first carefully look at what we already calculated. So let's look at the functions. Let's call, well, we have a function, let's call it now f of t. Okay. And on one side, we're going to write f of t. On the other side, we're going to write derivative. And if I use the previous notation, I would write it like this, df dt. But I would like to introduce a new notation, which I'm going to use often in the future. And that is f prime. It's just more simple, easier to write than writing df dt. There's nothing more in that. So what functions so far we looked at? We look at constant. We said the derivative of constant is 0. We look at linear function t. We said derivative is 1. We look at t squared. We said it's 2t. We look at t cubed. We said it 3t squared. We look at 1 over t. We said it's minus 1 over t squared. And we look at square root of x, square root of t, and we got 1 over 2 square root of t. Now, is there something in common with all these formulas? Well, let's look at all of them except for the first one. Let's just look at what's below this orange line. Just to give you some help, just let's remind you, what is t? T is t to the power of 1. 1 is t to the power of 0. 1 over t is t to the power of minus 1. And what we have here, minus 1 times t. 1 over t squared is t to the power of minus 2. Square root of t is t to the power of 1/2. And what we have here is 1/2 t to the power of minus 1/2. So does it give you, do you see any pattern here? Okay. And it turned out there's a pattern. If you see this, great. And the pattern is the following. If you have t to the power of n, and you want to take derivative out of it, the derivative is n to the power of t to the power of n minus 1. All right? And that formula works actually for any of those powers. We look power 1, 2, 3, minus 1, 1/2. In fact, this formula works for any n, when n is a real number. It could be positive, it could be negative, it could be integer, it could be non-integer. Any real number you want to take, this formula is going to work. So really, we don't really need to remember all these formulas. We don't really need to derive in general all these formulas. The whole thing we need to do is to remember that simple formula for arbitrary power n. So let me rewrite it again here in big fat letters, t to the power n. As I said, we would like to use, or I would like to use symbol prime as an indication of a derivative. And this is our formula. Now, since it's worked for any n, well, we can take whatever we want. For example, if somebody want to take n squared of 2, well, somebody crazy come to you and say, well, tell me what's the derivative of this thing. You say, well, first you should probably ask that person what is t to the power of square root of 2. Let him explain it to you. But anyway, it doesn't matter what it is. We just apply our formula, which is going to be square root of 2, t to the power of square root of 2 minus 1. You want to take t to the power of pi? Be my guest. It's going to be pi t, oopsie, 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 t to the power of pi minus 1. And it works for any power you want. All right? So that's it for this video. In the next video, we continue talking about some, general formulas for the derivatives. The formulas where we don't need to actually go back to calculating the limit. See you then.